The agenda for this particular video goes like this. We will see a brief of what is Strangler application pattern because we saw that in a separate video, but I'm going to show you why we need anti-corruption layer within a Strangler application pattern. So we will just brief about what is that, and we will look at what are the challenges in the Strangler application pattern and how you cannot use just only that particular pattern to go from monolith to microservices, and why you would require an anti-corruption pattern for it. We will look at when to use it. Also, we will look at a case study using the e-commerce application, which is the same application which we saw with the Strangler application pattern. Finally, we will end up with limitations and I will summarize this whole video. With that, let's get started. So monolithic to microservices. If you had seen the Strangler application pattern, we picked up a monolithic application and this is how the application looks like. So the application has modular components like UI, payments, products, authentication, and different other services. We converted this particular application into microservices, something like this. So we had the UI and also different applications which were connecting to the backend. We had an authentication layer which had its own database. We also had orders, products, payments talking to these authentication layer, and they also had their own databases. Using discovery service, all these services were able to identify themselves, and using an API gateway, we abstracted all these services from the UI or the interfaces. This is how we developed a Strangler application. And for a Strangler application, you need to have modular code base, right? Some of you had mentioned that not always monolithic applications have modular code bases, right? So in that case, what will I do? So this is where the anti-corruption layer will help us to fill that gap. So what are the challenges with respect to the Strangler application? Even though this particular code base is modular and we can easily split the application, there are different integration points and there could be different roadmaps for individual microservices. And I don't think we will have everything in one go. So in that case, we will have to follow a different pattern over a period of time before we completely transition into a microservices architecture. So let's look at the challenges in this architecture. The first challenge is the API design. What if the existing application followed a non-linear or non-semantic based API pattern? For example, I might have had different endpoints doing different operations. For example, here I have just laid out three different endpoints, one called get orders, the other called create orders, and then the other called delete orders. These doesn't necessarily follow the API standards. However, it just has some random names as the verbs, and then we were doing some different operation. So we may not be able to directly replicate the same. We may have to have something done here. The other thing is the data design, right? With respect to the tables, there could be a single table and then you could have had payment information, cards information also in the single order table, right? So the table is not split, so we will have to split the table as well. So now how do I handle it? So if I split it, then all the other services also needs to be taken care. For example, if I split the order table, then I need to have product and cards table designed at the same time, right? The payments and the card table designed at the same time. Both of the teams might have their own roadmaps, they might have their own priority. We will have to do these in parallel. So the cost of maintaining or refactoring the whole application is huge. So this is where anti-corruption layer helps us. So anti-corruption layer should be used when you want to have integration between legacy systems and also the new systems. So in our case, we had the legacy system, which was the old monolithic application, and we had been building new microservices based application, and we want to have a prolonged period of time in terms of transitioning from monolithic to microservices. This is where anti-corruption layer will help us. Also, imagine that there are other applications which are outside of our purview, and then they are consuming our APIs or they're just connecting to our application. In that case, they might follow different strategies and they might have different timelines and semantics, which will be specific to their team. They might say that, oh no, I don't want to change the API now from this particular URL to this particular URL. So they may have a pushback and we will have to end up maintaining both of them. So in that case, again, we will be using an anti-corruption layer. Now, what does this anti-corruption layer really mean, right? Let's bring the existing architecture which we saw. I'm going to introduce a new process or a new service called the anti-corruption layer or anti-corruption service, right? Generally, this particular service is an adapter or a facade which will plug into the existing data model, and also it will convert the existing data model into the new data model or API design. For example, my UI might still use the same endpoints. However, the anti-corruption layer will translate from the old endpoint to the new endpoint. Same way, if my consumers are consuming old SOAP endpoints, I might be using REST endpoints, then anti-corruption layer might be still exposing SOAP, but then I might be translating that into the corresponding new age REST endpoints internally. So anti-corruption layer is just another process which is going to translate our endpoints from the old to the new ones. So this kind of a pattern will help us in transitioning from monoliths to microservices, from legacy systems to newer modern systems when we are in a transition phase. Of course, you will have to get rid of the whole anti-corruption layer at one point, but then you will have to have a transition phase or a period over which you will have to smoothly transition your customers or clients. So that's when you will have to have an anti-corruption layer. And this is what the pattern says. So internally, what would happen in an anti-corruption layer is this is what would happen. For example, we have the API design, which had get orders, create orders, and delete orders. The whole anti-corruption layer will expose the same endpoints. However, it will translate and call the corresponding microservices. For example, the get orders, create, and delete orders might be translated into the corresponding API standards, which were defined by the new microservices. However, it will be exposing the old ones to the consumers. So you may not see the difference between the existing process and the new process because you're consuming off of the corrupted layer, which is the anti-corruption layer. So this way we would have preserved what is happening underneath. The same way, if let's say we had SOAP endpoints, like I mentioned, SOAP might be using a post, and internally you had different types of messages: get, create, and delete. You can convert them into the corresponding REST standards, whichever the microservices has designed. Of course, every design comes with a limitation. So even in this particular pattern, there are a lot of limitations. However, it solves different use cases, but it brings in some limitations which you need to be aware of. When you add more service, you add more latency. So with anti-corruption layer, when we add more service calls, we're going to have one more layer of jump from the consuming application to the anti-corruption, and from anti-corruption to the other services. So that's where latency is a addition here. So it will add more latency. Also, when you add more service, which is the anti-corruption service, it will add maintainability to the application. It will also add scalability factor. It also will add the observability factor. So you will have to now monitor, scale one more application in addition to the existing ones. And finally, it also adds up to the scope of your application layer, because when, let's say, I add a new feature, then you will have to end up exposing a new API from the anti-corruption layer. Or if I change an existing layer, or if I change an existing endpoint, then I will have to expose that in the anti-corruption layer as well. So you will have to do double the effort in terms of managing the translation layer, in terms of adding new features or removing any existing feature. These are some of the limitations in the anti-corruption layer. However, if you think it will solve majority of the problem with respect to migrating from monoliths to microservices, then definitely you can go ahead and use this particular pattern. Let me summarize what we just discussed. We initially saw the Strangler application pattern for converting monoliths to microservices. Then we saw some of the challenges in the Strangler application pattern. We also saw when to use the anti-corruption pattern, where we are going to use Strangler application pattern. We also saw the use case of the e-commerce application with the same example which we had in Strangler application pattern. We finally ended up with the limitations of anti-corruption pattern. I hope this particular video would have helped you in understanding different patterns with respect to migrating your application from monoliths to microservices. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.